October 12, 1944. Imperial Navy Headquarters, Kure, Japan. The teacup shattered against the mahogany floor as Admiral Takeshi Nakamura's hand trembled reading the reconnaissance report. 15 aircraft carriers, not the 3 they had calculated, not the 5 their best intelligence estimates suggested. 15 massive floating airfields steaming toward the Philippines, each one capable of launching more aircraft than Japan had left in its entire Pacific fleet. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra special for you. The silence in the war room stretched like a taut wire. Vice Admiral Kenji Sasaki, head of Naval Intelligence, cleared his throat nervously. "Sir, there must be some error in the count. Perhaps the pilots confused escort carriers with fleet carriers, or mistook tankers for—" His voice trailed off as Nakamura's cold stare silenced him. They both knew there was no error. The Americans had achieved the impossible, building a carrier fleet that defied every calculation, every prediction, every assumption upon which Japan's Pacific strategy had been based. What neither admiral understood was that this moment of shock had been predicted with chilling accuracy 3 years earlier by a man they had dismissed as a defeatist. Commander Hiroshi Matsuda had stood in this very room in 1941, holding blueprints and production schedules, warning that American shipbuilding capacity would produce carrier fleets beyond Japanese comprehension. He had been transferred to a remote weather station in the Kurils for his pessimistic assessments. Now, as Nakamura stared at the reconnaissance photos of the largest naval task force in human history, Matsuda's words echoed like a death knell across the Pacific. Commander Hiroshi Matsuda was born into a family that understood the sea's dangers intimately. His father, Captain Ichiro Matsuda, had commanded merchant vessels trading between Yokohama and San Francisco before the Great War, carrying silk westward and machinery eastward in the delicate dance of Pacific commerce. The elder Matsuda had returned from each voyage with stories that shaped his son's understanding of American industrial capacity. He spoke of harbors filled with ships under construction, of steel mills whose glow lit the night sky, of rail networks that moved raw materials with clockwork precision across a continent. Young Hiroshi absorbed these tales while excelling at the Naval Academy in Etajima, where his mathematical aptitude caught the attention of his instructors. Unlike his classmates who dreamed of commanding battleships in glorious surface engagements, Matsuda found himself fascinated by logistics, production schedules, and industrial planning. His graduation thesis, titled Maritime Industrial Capacity as a Determinant of Naval Power, earned him both academic honors and suspicion from traditionalist officers who viewed such concerns as beneath the warrior's code. In 1925, at the age of 26, Lieutenant Matsuda received orders that would change his life and, ultimately, the trajectory of the Pacific War. The Imperial Navy, recognizing the need for officers who understood modern shipbuilding techniques, was sending him to study naval architecture at the Massachusetts Institute of Technology in Cambridge. The assignment came with a specific mandate to observe American shipyard operations and report on their production capabilities. What his superiors expected was a routine intelligence gathering mission. What they got was a complete transformation of Matsuda's worldview. Matsuda arrived in Boston aboard the steamer Asama Maru on a crisp October morning in 1925. The city's harbor immediately overwhelmed him with its scale and activity. Dozens of vessels moved through channels marked by electric buoys, guided by radio communications that eliminated the confusion typical of Japanese ports. Steam cranes operated around the clock, loading and unloading cargo with mechanical precision. But it was the shipyard that truly captured his attention. The Four River Shipbuilding Corporation in Quincy employed 12,000 workers across facilities that covered 800 acres. The yard operated 3 shifts daily, with electric lighting allowing construction to continue through the night. Matsuda spent his first week simply walking the perimeter, timing the movement of materials, counting the number of cranes, observing the flow of workers entering and leaving. The scale defied his Japanese frame of reference. This single facility employed more workers than Japan's 3 largest shipyards combined. His studies at MIT provided the theoretical foundation for understanding what he observed empirically. Professor Harold Morrison's course in industrial engineering introduced Matsuda to concepts that were virtually unknown in Japan. Time and motion studies that eliminated inefficient movements, statistical quality control that reduced defects, continuous flow production that minimized delays, supply chain optimization that coordinated dozens of subcontractors. These were not merely academic theories, but practical methodologies being implemented in American shipyards. Matsuda's dormitory room in Cambridge became a shrine to American industrial documentation. Technical journals, production reports, industry statistics, and economic analyses covered every surface. His roommate, a chemistry student from Ohio, later recalled that Matsuda slept only 4 hours nightly, spending the remainder of his time translating American industrial reports into detailed Japanese analyses. The future commander was not merely studying naval architecture, he was dissecting the anatomy of American manufacturing supremacy. The revelation came during his first visit to the New York Navy Yard in Brooklyn. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means Matsuda had obtained permission to observe construction of the aircraft carrier Saratoga, one of 2 massive vessels being converted from battle cruiser hulls. The ship was beyond anything in the Japanese fleet, capable of operating 90 aircraft from a flight deck spanning 880 feet. But the vessel itself was less significant than the industrial ecosystem that created it. The conversion required steel from Pennsylvania, aluminum from Tennessee, electrical systems from Ohio, and optical equipment from New York. Yet materials arrived precisely when needed, coordinated by telephone networks and transportation systems that functioned with mechanical regularity. Matsuda calculated that the steel delivered to Brooklyn in a single week exceeded Japan's monthly production. The electrical generators installed in Saratoga consumed more power than most Japanese cities. During the summer of 1926, Matsuda embarked on an unauthorized expedition that would provide the foundation for his later warnings about American carrier production. Using his student status and fluent English, he traveled to shipyards across the eastern seaboard, posing as a graduate researcher studying comparative manufacturing techniques. His journey took him to Philadelphia, Norfolk, Newport News, and Charleston, where he observed shipbuilding operations that reinforced his growing understanding of American industrial superiority. The Newport News Shipbuilding and Dry Dock Company particularly impressed him with its integrated approach to vessel construction. The facility produced its own steel, manufactured its own engines, and trained its own specialized workers. Most remarkably, it operated its own technical school that graduated 500 skilled shipbuilders annually. Japan's entire naval construction program relied on fewer skilled workers than this single facility trained each year. Matsuda's most significant discovery came during his visit to the Electric Boat Company in Groton, Connecticut, where he observed submarine construction using assembly line techniques adapted from automotive manufacturing. Hulls moved through stations where specialized teams performed specific tasks with practiced efficiency. Welding, pipe installation, electrical work, and testing occurred in predetermined sequences that eliminated delays and reduced errors. The company produced submarines faster and more reliably than Japanese yards built destroyers. The technical education Matsuda received at MIT equipped him to understand the mathematics underlying American production superiority. His courses in metallurgy revealed why American steel was stronger and more consistent than Japanese alternatives. Studies in electrical engineering explained the power generation systems that operated American shipyards continuously. Training in industrial chemistry eliminated the processes that produced specialized alloys, fuels, and lubricants essential for modern naval operations. But Matsuda's most crucial insight came from Professor Morrison's lectures on production scaling. The professor explained how American manufacturing systems were designed for rapid expansion during emergencies. Automotive factories could be converted to produce aircraft engines within months. Steel mills could increase output by adding shifts and equipment. Most importantly, the workforce possessed technical skills that could be quickly adapted to new production requirements. This flexibility represented a fundamental difference between American and Japanese manufacturing philosophies. Japanese yards optimized for producing small numbers of highly crafted vessels using traditional techniques passed down through generations of shipbuilders. American facilities emphasized standardization, mechanization, and rapid production using interchangeable components and systematic processes. In peacetime, the Japanese approach produced superior individual vessels. In wartime, American methods would prove decisively advantageous. Matsuda's investigations extended beyond shipbuilding to the broader industrial infrastructure supporting American naval power. He visited steel mills in Pittsburgh where blast furnaces operated continuously, producing more steel in a day than Japanese mills produced in a week. Railroad networks moved raw materials and finished products with schedules coordinated by telegraph systems spanning the continent. Electric power grids supplied energy for industrial operations on a scale that Japanese planners considered impossible. The aluminum industry particularly fascinated Matsuda because he understood its implications for aircraft carrier construction. The Aluminum Company of America operated facilities that consumed enormous quantities of electricity to refine bauxite into lightweight metal essential for aircraft production. The company's Niagara Falls plant alone used more electricity than the entire city of Tokyo. This industrial capacity would prove crucial when America began mass production of carrier-based aircraft. During his final year at MIT, Matsuda compiled his observations into a comprehensive analysis that should have revolutionized Japanese naval planning. His report, titled American Shipbuilding Capacity and Strategic Implications, predicted that the United States could construct aircraft carriers at rates exceeding Japan's ability to sink them. More specifically, he calculated that American yards could produce 15 to 20 fleet carriers within 3 years of full mobilization. The mathematical foundation for this prediction was solid. American steel production exceeded Japan's by a factor of 12. Electrical generating capacity was 20 times greater. Aluminum production was virtually unlimited compared to Japan's minimal output. Most crucially, American shipyards employed standardized construction techniques that could be rapidly expanded by adding workers and equipment rather than requiring years to train craftsmen. This flexibility represented a fundamental difference between American and Japanese manufacturing philosophies. Japanese yards optimized for producing small numbers of highly crafted vessels using traditional techniques passed down through generations of shipbuilders. American facilities emphasized standardization, mechanization, and rapid production using interchangeable components and systematic processes. In peacetime, the Japanese approach produced superior individual vessels. In wartime, American methods would prove decisively advantageous. Matsuda's investigations extended beyond shipbuilding to the broader industrial infrastructure supporting American naval power. He visited steel mills in Pittsburgh, where blast furnaces operated continuously, producing more steel in a day than Japanese mills produced in a week. Railroad networks moved raw materials and finished products with schedules coordinated by telegraph systems spanning the continent. Electric power grids supplied energy for industrial operations on a scale that Japanese planners considered impossible. The aluminum industry particularly fascinated Matsuda because he understood its implications for aircraft carrier construction. The Aluminum Company of America operated facilities that consumed enormous quantities of electricity to refine bauxite into lightweight metal essential for aircraft production. The company's Niagara Falls plant alone used more electricity than the entire city of Tokyo. This industrial capacity would prove crucial when America began mass production of carrier-based aircraft. During his final year at MIT, Matsuda compiled his observations into a comprehensive analysis that should have revolutionized Japanese naval planning. His report, titled American Shipbuilding Capacity and Strategic Implications, predicted that the United States could construct aircraft carriers at rates exceeding Japan's ability to sink them. More specifically, he calculated that American yards could produce 15 to 20 fleet carriers within 3 years of full mobilization. The mathematical foundation for this prediction was solid. American steel production exceeded Japan's by a factor of 12. Electrical generating capacity was 20 times greater. Aluminum production was virtually unlimited compared to Japan's minimal output. Most crucially, American shipyards employed standardized construction techniques that could be rapidly expanded by adding workers and equipment rather than requiring years to train craftsmen. Matsuda's analysis included detailed sketches of American shipyard layouts, production flowcharts showing how materials moved through construction processes, and time studies demonstrating the efficiency of American techniques. He had observed multiple aircraft carrier constructions simultaneously, noting how yards could produce several vessels concurrently using parallel production lines. The report concluded with a stark warning that proved prophetic. If Japan engaged in prolonged warfare with the United States, American industrial capacity would produce naval forces that would overwhelm Japanese defenses through sheer numerical superiority. Specifically, Matsuda predicted that American carrier fleets would eventually include 15 or more fleet carriers operating simultaneously, supported by production facilities capable of replacing losses faster than Japan could inflict them. Upon completing his studies in 1928, Matsuda returned to Japan carrying documentation, photographs, and calculations that provided a complete picture of American naval construction capabilities. His superiors at Navy headquarters received his report with polite interest, but dismissed its implications as overly pessimistic. Traditional Japanese naval doctrine emphasized quality over quantity, spiritual superiority over material advantage, and tactical brilliance over industrial production. The young commander found himself assigned to the Naval War College in Tokyo, where he was expected to integrate his American observations into conventional Japanese strategic thinking. Instead, Matsuda used his position to conduct detailed analyses comparing Japanese and American naval construction capabilities. His lectures to junior officers emphasized the mathematical realities of modern naval warfare, where victory increasingly depended on production capacity rather than individual ship quality or crew training. Matsuda's teachings attracted both devoted followers and fierce critics within the naval establishment. Progressive officers recognized the validity of his industrial analysis and began incorporating production considerations into their strategic planning. Traditionalists viewed his emphasis on manufacturing capacity as defeatist thinking that undermined Japanese spiritual superiority and warrior traditions. The resistance to Matsuda's ideas reflected deeper cultural tensions within the Imperial Navy. Many senior officers had been trained during the era of Admiral Togo's victory over Russia, when Japanese tactical excellence had overcome material disadvantage. They believed that superior training, better equipment, and spiritual dedication could compensate for numerical inferiority. Matsuda's mathematical analyses threatened these comfortable assumptions by demonstrating that modern warfare had become an industrial equation, where quantity ultimately determined victory. Throughout the 1930s, as Japan expanded its military operations in China and prepared for broader Pacific conflict, Matsuda continued refining his calculations of American production potential. He maintained correspondence with former MIT classmates who provided updates on American shipbuilding developments. These reports confirmed his predictions about expanding American naval construction capabilities and growing technical sophistication in carrier aviation. By 1940, Matsuda had developed comprehensive projections showing how American aircraft carrier production would accelerate once the nation fully mobilized for war. His calculations indicated that peak production would reach levels that Japanese planners considered impossible. American yards would eventually launch fleet carriers monthly while maintaining simultaneous production of dozens of escort carriers. The industrial mathematics were unforgiving. Japan could not compete with such production capacity under any circumstances. The final validation of Matsuda's MIT education came through his analysis of American naval expansion programs announced in 1940 and 1941. The Two-Ocean Navy Act authorized construction of naval forces exceeding the entire Japanese fleet, including multiple aircraft carriers using construction techniques Matsuda had observed during his American studies. The legislation provided funding levels that exceeded Japan's entire national budget, demonstrating American economic capacity to sustain prolonged warfare. Commander Matsuda had spent 15 years studying American industrial capabilities, first as a student at MIT and subsequently as an analyst at the Naval War College. His conclusions were mathematically precise and strategically devastating. American shipyards would produce aircraft carrier fleets that would dominate the Pacific through numerical superiority. Specifically, he predicted that American task forces would eventually include 15 or more fleet carriers operating simultaneously, supported by construction programs capable of maintaining such forces indefinitely. These predictions, derived from careful observation of American industrial processes and detailed mathematical analysis of production capabilities, would prove accurate to a degree that shocked even Matsuda himself. But in 1941, as Japan prepared for war with the United States, his warnings were dismissed as the pessimistic calculations of an officer too influenced by American thinking. The Imperial Navy preferred comfortable illusions about spiritual superiority to uncomfortable truths about industrial mathematics. The stage was set for a confrontation between Japanese confidence and American production capacity, with Commander Matsuda's predictions serving as an unheeded prophecy of the numerical overwhelming that would ultimately determine the Pacific War's outcome. Commander Matsuda returned to Tokyo in March 1929, carrying what he believed would be the most important intelligence briefing in Imperial Navy history. His suitcase contained detailed blueprints of American shipyard layouts, production schedules from major naval construction facilities, and comprehensive analyses of industrial capacity that painted a terrifying picture of American potential. The mathematical evidence was overwhelming. American shipbuilding capability exceeded Japanese capacity by margins so vast they seemed almost fictional. Yet as Matsuda prepared his presentation for senior naval leadership, he already sensed the resistance that would greet his findings. The briefing room at Navy headquarters felt oppressively formal as Matsuda spread his charts across the polished conference table. Admiral Yoshimura Tanaka, Chief of Naval Operations, examined the documents with polite interest while his staff officers maintained the neutral expressions required by Japanese military protocol. Matsuda began with production statistics, showing how American steel output dwarfed Japanese capability, how electrical generating capacity enabled continuous shipyard operations, how transportation networks moved materials with systematic efficiency unknown in Japan. The presentation proceeded methodically through his calculations. American shipyards employed standardized construction techniques that could be rapidly scaled upward during wartime mobilization. Training programs produced skilled workers faster than Japan could educate traditional craftsmen. Supply chains coordinated hundreds of subcontractors with mechanical precision. Most critically, the aircraft carrier construction programs he had observed demonstrated Americans' ability to build multiple large vessels simultaneously, using parallel production methods. Admiral Tanaka interrupted during Matsuda's discussion of carrier aviation capabilities. The senior officer questioned whether American pilots could match the skill and dedication of Japanese naval aviators, suggesting that superior training might compensate for numerical disadvantage. Matsuda responded carefully, acknowledging Japanese pilot quality while emphasizing that American production would eventually overwhelm any tactical advantages through sheer volume of aircraft and carriers. The mathematical projections Matsuda presented should have terrified his audience. He calculated that American yards could construct 15 fleet carriers within 4 years of full mobilization, supported by escort carrier production that would reach unprecedented levels. These vessels would operate aircraft produced in quantities that Japanese manufacturing could never approach. The industrial equation was unforgiving. American production capacity would create naval forces that no tactical brilliance could overcome. Captain Shuzo Kawamoto, head of naval intelligence, challenged Matsuda's methodology. He argued that the young officer's American education had created unrealistic admiration for foreign capabilities, while undermining confidence in Japanese spiritual superiority. The captain suggested that American industrial statistics might be inflated, that democratic societies lacked the discipline necessary for sustained military production, that Japanese warrior tradition would prove decisive despite material disadvantage. Matsuda recognized the futility of logical argument against ideological conviction. His charts and calculations demonstrated mathematical reality, but his superiors preferred comfortable assumptions about Japanese superiority to uncomfortable truths about American capability. The stage was set for a confrontation between Japanese confidence and American production capacity, with Commander Matsuda's predictions serving as an unheeded prophecy of the numerical overwhelming that would ultimately determine the Pacific War's outcome. Commander Matsuda returned to Tokyo in March 1929, carrying what he believed would be the most important intelligence briefing in Imperial Navy history. His suitcase contained detailed blueprints of American shipyard layouts, production schedules from major naval construction facilities, and comprehensive analyses of industrial capacity that painted a terrifying picture of American potential. The mathematical evidence was overwhelming. American shipbuilding capability exceeded Japanese capacity by margins so vast they seemed almost fictional. Yet as Matsuda prepared his presentation for senior naval leadership, he already sensed the resistance that would greet his findings. The briefing room at Navy headquarters felt oppressively formal as Matsuda spread his charts across the polished conference table. Admiral Yoshimura Tanaka, Chief of Naval Operations, examined the documents with polite interest while his staff officers maintained the neutral expressions required by Japanese military protocol. Matsuda began with production statistics, showing how American steel output dwarfed Japanese capability, how electrical generating capacity enabled continuous shipyard operations, how transportation networks moved materials with systematic efficiency unknown in Japan. The presentation proceeded methodically through his calculations. American shipyards employed standardized construction techniques that could be rapidly scaled upward during wartime mobilization. Training programs produced skilled workers faster than Japan could educate traditional craftsmen. Supply chains coordinated hundreds of subcontractors with mechanical precision. Most critically, the aircraft carrier construction programs he had observed demonstrated Americans' ability to build multiple large vessels simultaneously, using parallel production methods. Admiral Tanaka interrupted during Matsuda's discussion of carrier aviation capability. The briefing concluded with polite thanks for his diligent research and suggestions that he focus on more immediate tactical concerns rather than speculative strategic projections. The isolation began immediately after his presentation. Fellow officers who had previously sought Matsuda's advice on technical matters now avoided extended conversations. His requests for assignment to strategic planning positions were denied in favor of routine administrative duties. The Naval War College, where he had expected to continue his analytical work, assigned him to teach basic navigation rather than industrial warfare concepts. Captain Kawamoto's subsequent evaluation of Matsuda's fitness reports contained subtle but damaging criticisms. The commander showed excessive admiration for foreign practices. His analyses demonstrated insufficient confidence in Japanese capabilities. His mathematical approach to warfare neglected spiritual factors that determined victory. These coded phrases effectively ended Matsuda's prospects for advancement while maintaining the appearance of objective personnel evaluation. Despite official discouragement, Matsuda continued refining his calculations as American naval expansion accelerated throughout the 1930s. He maintained unofficial correspondence with MIT classmates who provided updates on shipbuilding developments. The information confirmed his predictions about expanding production capabilities and growing sophistication in carrier aviation technology. American yards were implementing construction techniques that would enable rapid wartime mobilization exactly as he had forecast. The validation of his industrial analysis provided cold satisfaction as Matsuda watched American naval programs grow beyond Japanese comprehension. The Vincennes Naval Acts of 1934 and 1938 authorized construction exceeding the entire Imperial Navy strength. The Two Ocean Navy Act of 1940 approved funding levels that surpassed Japan's national budget while mandating carrier construction programs that would fulfill his most pessimistic projections. By 1940, Matsuda had documented American progress toward the 15-carrier fleet he had predicted. The Essex-class program alone would produce 24 fleet carriers using standardized designs that enabled rapid construction. Independence-class light carriers would add another 9 vessels converted from cruiser hulls. Escort carrier programs would eventually produce over 100 vessels using merchant ship construction techniques adapted for military purposes. The numbers were staggering even to Matsuda, who had calculated their possibility years earlier. American industry was creating naval forces that exceeded the combined fleets of all other nations. More importantly, production rates were accelerating as construction techniques improved and manufacturing capacity expanded. The mathematical reality he had discovered at MIT was manifesting with precision that validated every calculation while demonstrating the futility of Japanese resistance. Lieutenant Commander Kenji Watanabe, one of Matsuda's former students, approached him privately in late 1940 with intelligence reports suggesting imminent war with the United States. The younger officer requested Matsuda's assessment of Japanese prospects given American naval expansion programs. The conversation took place in a secluded garden behind the War College, where surveillance was impossible and honest discussion could occur without official consequences. Matsuda's response was mathematically precise and strategically devastating. Japanese naval forces might achieve initial tactical victories through superior training and preparation, but American industrial capacity would rapidly overwhelm any advantages. Specifically, he predicted that American carrier task forces would eventually include 15 or more fleet carriers, supported by dozens of escort carriers and hundreds of supporting vessels. No island nation dependent on imported resources could sustain warfare against such industrial capacity. Watanabe pressed for more specific projections about the war's likely duration and outcome. Matsuda calculated that Japan might maintain offensive capability for approximately 18 months before American production achieved decisive superiority. After that point, mathematical certainty would determine the conflict's conclusion. American yards would replace losses faster than Japanese forces could inflict damage, while producing new vessels that exceeded Japan's construction capacity by overwhelming margins. The conversation concluded with Watanabe's request for written analysis that could be shared with other progressive officers who questioned the wisdom of war with America. Matsuda declined, understanding that such documentation would provide evidence for treason charges if discovered by military police. His verbal warnings would have to suffice, though he doubted they would influence strategic decisions already made by leaders who preferred mystical beliefs to mathematical reality. Throughout 1941, as diplomatic negotiations deteriorated and military preparations, Matsuda found himself consulted unofficially by junior officers who understood the implications of American industrial capacity. These conversations occurred in private settings where honest assessment could occur without official repercussions. The pattern was always the same. Officers who had observed American strength firsthand sought confirmation of their fears, while those trained in traditional Japanese doctrine dismissed material considerations as irrelevant to spiritual warfare. The attack on Pearl Harbor vindicated Matsuda's predictions about American vulnerability to surprise assault, while confirming his fears about the strategic consequences. Japanese forces achieved tactical success that exceeded planning expectations, damaging American battleships and aircraft while suffering minimal losses. The victory parades in Tokyo celebrated what appeared to be decisive defeat of American naval power in the Pacific. Matsuda watched these celebrations with growing dread, knowing they marked the beginning of Japan's inevitable destruction. Admiral Chuichi Nagumo's carrier task force had struck the American Pacific Fleet precisely as Matsuda had calculated was possible. Superior training, careful preparation, and tactical surprise had overcome material disadvantage to achieve stunning initial success. But Matsuda understood that this victory was temporary, purchased at the cost of arousing American industrial capacity that would respond with overwhelming force. The sleeping giant had awakened exactly as he had predicted. Intelligence reports from Pearl Harbor confirmed both the extent of tactical success and the limitations of strategic achievement. American aircraft carriers had escaped destruction through fortunate absence during the attack. Fuel storage facilities and repair yards remained largely intact, enabling rapid recovery of operational capacity. Most critically, the attack had unified American public opinion behind total war rather than negotiated settlement, ensuring that full industrial mobilization would follow. Matsuda's analysis of post-Pearl Harbor developments proved devastatingly accurate. American shipyards immediately accelerated production schedules while implementing continuous operation procedures he had observed during his MIT years. The efficiency improvements he had calculated became reality as yards adopted standardized construction techniques and parallel production methods. Within months, American naval construction was approaching the levels he had predicted would prove decisive. The Doolittle raid in April 1942 demonstrated American industrial recovery with shocking speed. The bombers that struck Tokyo had been launched from the carrier Hornet, which represented exactly the kind of rapid construction capability Matsuda had warned about. The vessel had been completed in less than 14 months using techniques he had observed at Newport News during his student years. More ominously, intelligence indicated that similar carriers were under construction at multiple American yards simultaneously. Captain Watanabe, now serving with the combined fleet, sent Matsuda encoded messages describing American naval forces encountered during Pacific operations. The reports confirmed expanding carrier aviation capabilities that matched his calculations about American production acceleration. More disturbing were descriptions of new American vessels that incorporated technological improvements unknown to Japanese designers. American industry was not merely producing more ships, but better ships using innovations that Japanese yards could not match. The Battle of the Coral Sea in May 1942 provided additional evidence of American industrial superiority despite tactical outcomes that appeared favorable to Japan. Intelligence analysis revealed that damaged American carriers were being repaired using techniques and equipment that enabled rapid return to service. Japanese vessels suffering similar damage required months of yard time using traditional repair methods. The disparity in maintenance capability reflected broader industrial advantages that would prove decisive over time. Matsuda's predictions about American carrier strength began manifesting with mathematical precision during the summer of 1942. Intelligence reports described American task forces operating multiple fleet carriers simultaneously, while escort carrier production provided additional aviation capacity for support operations. The 15-carrier fleet he had calculated as theoretically possible was becoming operational reality faster than even his optimistic projections had suggested. The isolation that had begun after his 1929 presentation intensified as Matsuda's predictions proved accurate. Fellow officers avoided association with the commander whose pessimistic assessments were being validated by unfolding events. His transfer to a weather monitoring station in the Kuriles was officially described as recognition of his technical expertise, but actually represented exile from strategic decision-making processes. From his remote posting, Matsuda continued tracking American naval construction through intelligence summaries and foreign press reports. The Essex-class carriers were entering service ahead of schedule, while Independence-class conversions provided additional aviation capability. More alarming were reports of escort carrier production that exceeded his calculations about American industrial capacity. The mathematics of naval warfare were playing out exactly as he had predicted, with results that terrified even their originator. Lieutenant Watanabe's final message reached Matsuda in September 1943, describing American naval forces that had grown beyond Japanese comprehension. Task Force 58 now included 15 fleet carriers operating as coordinated units with supporting vessels that outnumbered the entire combined fleet. The mathematical reality Matsuda had calculated 15 years earlier was now operational fact. American industry had created naval power that no amount of Japanese courage or tactical skill could overcome. The message concluded with Watanabe's acknowledgement that Matsuda's warnings had been completely accurate while Japanese leadership had chosen comfortable delusions over mathematical truth. The young officer requested permission to quote Matsuda's industrial analysis in final reports, but understood that such documentation would serve no purpose beyond historical record. The war's outcome had been determined by production statistics that Matsuda had calculated with precision that amazed even himself. Reading Watanabe's description of American carrier task forces, Matsuda felt the peculiar satisfaction of mathematical vindication combined with profound sorrow for his nation's fate. Every calculation he had made during his MIT years had proved accurate. Every prediction about American industrial capacity had been fulfilled. Every warning about the impossibility of victory had been ignored. The 15-carrier fleet that had seemed impossible to his superiors in 1929 was now devastating Japanese positions across mechanical efficiency that reflected American industrial superiority. Commander Hiroshi Matsuda had become history's most accurate prophet of naval warfare, cursed with perfect foresight that no one had wanted to hear. His MIT education had provided the mathematical tools for calculating American victory, while his isolation prevented him from influencing strategic decision-making processes. The burden of knowledge had made him a witness to his nation's predetermined destruction, armed with calculations that proved the futility of resistance while being powerless to prevent the catastrophe he had foreseen with such devastating precision. Part 3. Prophecy Fulfilled. October 24, 1944. The Kure weather station where Commander Matsuda had spent 18 months recording wind speeds and atmospheric pressure became ground zero for intelligence that would shatter Japanese naval confidence forever. Radio operator Seaman First Class Takeshi Yamada burst into Matsuda's meteorological office clutching decoded intercepts from reconnaissance aircraft over the Philippine Sea. The messages were fragmentary, transmitted by pilots whose voices cracked with disbelief as they reported American naval forces that defied comprehension. 15 aircraft carriers steaming in coordinated formation, their flight decks black with aircraft that outnumbered the entire Japanese carrier aviation remaining in the Pacific. Task Force 38 had materialized exactly as Matsuda's MIT calculations had predicted 15 years earlier. A floating industrial empire that represented American production capacity transformed into devastating naval power. Each Essex-class carrier operated 90 aircraft, while Independence-class light carriers added their own aviation groups to the armada that now dominated Pacific waters. Matsuda read the reconnaissance reports with the strange calm of vindicated prophecy. Every specification matched his projections about American shipbuilding acceleration. The standardized construction techniques he had observed in Massachusetts were producing identical vessels with mechanical regularity. Parallel production methods had enabled simultaneous construction at multiple yards, creating the massive carrier fleet that his superiors had dismissed as impossible fantasy. The radio crackled with additional reports as Japanese reconnaissance aircraft attempting to count the American vessels before being driven off by swarms of Hellcat fighters. Escort carriers accompanied the main force, providing additional aviation capability while demonstrating the depth of American industrial mobilization. These smaller vessels, converted from merchant hulls using techniques Matsuda had studied at Electric Boat, represented production capacity that Japanese yards could never approach. Admiral Takeshi Nakamura's frantic communications from Combined Fleet Headquarters revealed the complete breakdown of Japanese strategic assumptions. Intelligence estimates had predicted 3 American carriers in the Philippine area, possibly 5 at maximum strength. The 15 fleet carriers now approaching represented mathematical impossibility according to traditional Japanese planning. Nakamura's staff was requesting immediate confirmation of the count, hoping desperately that pilot error or optical illusion might explain the overwhelming force bearing down on Japanese positions. Matsuda composed his response with surgical precision, drawing on calculations he had refined over 2 decades of analyzing American industrial capacity. The carrier count was accurate and represented only the beginning of American naval expansion. Construction programs currently underway would produce additional Essex-class vessels, while escort carrier production would exceed 100 vessels total. The mathematical projection he had presented in 1929 was manifesting with precision that demonstrated the inexorable logic of industrial warfare. The communication to Admiral Nakamura included specific technical details that validated Matsuda's credibility while emphasizing the futility of Japanese resistance. American carriers operated aircraft whose performance exceeded Japanese capabilities through superior manufacturing techniques and unlimited fuel supplies. Pilot training programs had overcome initial quality disadvantage through massive expansion that produced competent aviators faster than Japan could train replacements for combat losses. Most devastatingly, Matsuda's analysis revealed that the 15-carrier task force represented sustainable American capability rather than temporary concentration of available forces. Shipyard production schedules would maintain such fleet strength indefinitely while replacing combat losses with improved vessels incorporating technological advances. Japanese forces faced not merely numerical overwhelming, but continuous industrial regeneration that made victory mathematically impossible. The communication to Admiral Nakamura included specific technical details that validated Matsuda's credibility while emphasizing the futility of Japanese resistance. American carriers operated aircraft whose performance exceeded Japanese capabilities through superior manufacturing techniques and unlimited fuel supplies. Pilot training programs had overcome initial quality disadvantage through massive expansion that produced competent aviators faster than Japan could train replacements for combat losses. Most devastatingly, Matsuda's analysis revealed that the 15-carrier task force represented sustainable American capability rather than temporary concentration of available forces. Shipyard production schedules would maintain such fleet strength indefinitely while replacing combat losses with improved vessels incorporating technological advances. Japanese forces faced not merely numerical overwhelming, but continuous industrial regeneration that made victory mathematically impossible. The response from Tokyo demonstrated the complete psychological collapse of Japanese naval leadership when confronted with the reality Matsuda had predicted. Admiral Nakamura's staff had spent 3 days verifying the carrier count through multiple reconnaissance flights, hoping to discover errors that would reduce the American force to manageable proportions. Each additional sighting confirmed the presence of vessels that represented industrial achievement beyond Japanese comprehension. Vice Admiral Kenji Sasaki, head of naval intelligence, personally contacted Matsuda to request detailed analysis of American production capabilities based on his MIT research. The conversation occurred through encrypted channels that reflected the sensitive nature of discussing Japan's strategic hopelessness while the war continued. Sasaki's questions revealed complete ignorance of the industrial factors that had determined the war's outcome before the first shot was fired. Matsuda's briefing to Sasaki covered the mathematical foundations of American naval superiority with scholarly thoroughness that contrasted sharply with the desperate urgency of Japan's military situation. Steel production exceeding Japanese capacity by factors of 15 enabled continuous shipbuilding at rates that overwhelmed any tactical advantages. Electrical generation capabilities powered shipyards operating around the clock using techniques that eliminated traditional construction delays. The aluminum industry that Matsuda had studied in detail during his American years now produced aircraft in quantities that Japanese planners had considered impossible. American aviation manufacturers were delivering fighters and bombers using assembly line methods adapted from automobile production. Each month's output exceeded Japan's annual manufacturing capability while incorporating technological improvements that ensured qualitative superiority alongside numerical overwhelming. Oil production statistics that Matsuda recited from memory demonstrated the futility of Japanese strategic planning based on resource constraints. American petroleum output could sustain unlimited naval operations, while Japanese forces faced increasing fuel shortages that limited training and combat effectiveness. The industrial mathematics were unforgiving, victory required resources that Japan had never possessed, and production capabilities that American industry had developed systematically over decades. Admiral Sasaki's final question addressed the timeline for Japanese strategic collapse given current American production rates. Matsuda calculated that carrier aviation losses could not be replaced at rates necessary to maintain defensive capability. Within 6 months, Japanese naval aviation would cease to exist as an effective force while American carrier strength would continue expanding. The 15-carrier task force now operating in Philippine waters represented the beginning rather than the peak of American naval power. The Battle of Leyte Gulf commenced on October 23, with Japanese forces attempting desperate attacks against American invasion forces supported by the massive carrier fleet that Matsuda had predicted with such accuracy. The engagement demonstrated every aspect of American industrial superiority that his MIT analysis had identified decades earlier. Superior numbers, better equipment, unlimited fuel supplies, and continuous reinforcement capability combined to produce decisive victory that eliminated Japanese naval power permanently. Reports from the battle reached Matsuda through intelligence channels that painted a picture of complete Japanese defeat by forces that represented American manufacturing supremacy transformed into naval warfare. Task Force 38 operated with mechanical efficiency that reflected standardized training and equipment. Damage control procedures enabled rapid repair of battle damage using techniques and materials that Japanese vessels could not match. The mathematical precision of American victory vindicated every calculation Matsuda had made during his years of analyzing industrial capacity. Japanese tactical skill and individual courage could not overcome the systematic advantages that American production provided. Each American pilot flew aircraft produced in quantities that enabled replacement of losses within days rather than months required for Japanese manufacturing. Commander Hiroshi Matsuda died on November 15, 1944, during an American bombing raid that targeted the Kure weather station, where his warnings had been vindicated with such devastating accuracy. His final report, discovered among his personal effects, contained calculations showing how American carrier production would continue accelerating through 1945, while Japanese naval construction would cease entirely due to resource shortages and industrial collapse. The report concluded with mathematical projections that proved accurate to the day the war ended. American industrial capacity would produce naval forces exceeding the combined strength of all other nations while maintaining technological superiority through continuous innovation. Japan's fate had been determined by production statistics that Matsuda had calculated with precision that amazed even himself, armed with MIT education that enabled perfect foresight while being powerless to prevent the catastrophe he had predicted. The 15 aircraft carriers that shocked Japanese naval leadership in October 1944 represented exactly the industrial achievement that Commander Matsuda had calculated during his student years in Massachusetts. His tragedy was not mathematical error, but mathematical accuracy, cursed with perfect understanding of American production capacity while serving a nation that preferred comfortable delusions to uncomfortable truth. The prophet had spoken with devastating precision, and history had vindicated every prediction while destroying the empire that refused to listen. Up next, you've got 2 more standout stories right on your screen. If this one hit the mark, you won't want to pass these up. Just click and check them out.